Dashboards are great, but they don't wake you up at 2 a.m. What if your server crosses 90% CPU and no one notices? Today, we'll wire Prometheus plus Alertmanager plus Slack so your system speaks before users complain. We will start the stack, explain each and every file, deep dive node exporter, and watch a real alert hit Slack. The flow is very simple: node exporter, Prometheus, alert manager, Slack. Node exporter reads host metrics. Prometheus evaluates alerts. If a condition holds, Prometheus marks it firing and hands it to Alert Manager. Alert Manager decides where or how to notify Slack, for example, or email or Teams channel. We can have multiple options in this place, but for today, I want to keep it very simple and we are going to go with Slack. Before jumping into the demo, hit subscribe. Next episode will stage a production style outage and let alerts guide our debugging live. So I have episode 4 folder, alerting. In this folder, I have alertrules.yaml file, alertmanager.yaml, dockercompose.yaml, prometheus.yaml. First, I would like to start with dockercompose.yaml file. So in this file, we have seen in previous episodes, we had Prometheus, node exporter, followed by Grafana, and we are trying to add a new service, Alert Manager. First of all, before going to Alert Manager, I would like to give a small explanation here about node exporter. Previous node exporter had only image and ports, but this node exporter comes with PID. So what exactly is PID here? PID is nothing but process ID of our host machine. With host PID, it reports real host CPU, which is what we want for alerts. And in terms of volumes, we have proc, which is pointing out to host proc read only, /sys, host sys, then root fs. This combo makes node exporter behave as if it's running on the host even inside Docker. We are going to ignore this collector file system, mount these long expressions which we have, because on Windows WSL plus Docker desktop, you will see sudo mounts like /mount/WSL Docker desktop bind and stuff. These can create invalid file system metrics and noisy warnings like metric was collected before, skip noisy path, skip file systems. We are trying to add these flags here. Then we have Alert Manager with image and ports, followed by we are trying to attach alertmanager.yaml file. So this is the file we are trying to attach. Now let's jump to the prometheus.yaml file. In this file, the same, I think I already explained about this. We are trying to scrape this data for every 15 seconds. Then we have scrape configuration, job name, static config, followed by we have rule underscore files. It tells Prometheus where your alert rules live. We are trying to keep the rules in a separate file, as you can see, alertrules.yaml. Then we have alerting. This is nothing but dispatcher connection. Prometheus doesn't send Slack, it forwards firing alerts to Alertmanager at this particular port 9093. Alertmanager then groups, deduplicates, throttles, and send notification to Slack. Without this particular block, Prometheus would detect issues but stay silent. Now let's look at the actual alert rule. So what do we have here? Here we have groups, then followed by node alerts name, rules, alert name is high CPU usage, expression. We are trying to calculate average rate of node CPU per seconds total. Mode is user. For 1 minute, multiplying by 100, it should be less than 80. In production, it would be greater than 80. Wantedly, I am keeping it less than 80 so that we'll have some alerts. For 10 seconds, prevent noisy flip-flops. The condition must hold for 10 seconds to fire. Then we have labels, severity warning, annotation, summary is high CPU usage detected, description CPU usage less than 80% for more than 1 minute. So if this particular condition meets, then we are going to get the Slack alert. Now let's jump into the alertmanager.yaml file. Here we are trying to set the route. Receiver would be Slack notifications, receivers name, Slack config, send resolve true, the channel name, username, icon emoji, then the API URL. We have to create this on Slack. I'm going to show that in a moment. Once we have the URL, we are just going to replace this particular URL. Now let's jump back to Slack. So here I'm going to create a new channel. So for that I'm going to say add channel, create a new channel. Next, I would like to give channel name, for example, DevOps alerts, public anyone can access, or private only specific people can access. So I would say monitoring, because I think I already used this particular name. So I would say DevOps alerts monitoring, create, skip for now. We have the channel in place. Followed by I'm going to go to api.slack.com. Here you can create a new application. You can do it from a manifest. I would like to do it from scratch. Click on this and then application name. So what exact name you would like to give here? So I would give a name as Prometheus alert bot. Followed by select the workspace, learn with DevOps engineer, create application. It will take a minute. Followed by on the settings page, click on incoming webhook. Here try to turn on this. Followed by add new webhook. Then select the channel. So DevOps alert monitoring, which we created just now, DevOps alerts monitoring. Click allow. Once we have that, you will see a success message. Copy this URL. Go back to Visual Studio Code. Here we are going to replace this URL with the URL which we copied just now. Normally this should not be visible in production environments. We are going to use a different approach. We are trying to use environment variables and try to pass the URL. Or in CI/CD pipelines, we are going to pass this particular variable. Now we are ready. We need to update the channel name here. So for example, I'm going to go back to my channel. I would like to copy this channel name so that I will not make any mistakes. Jump back to Visual Studio Code and I would like to paste it here. Save this. Also, I would like to save this file as well. Now we are ready with all the files and configurations. Let's start our containers. For that, I am going to say docker compose up space hyphen build. As soon as our containers are up and running, we are going to jump back to our browser and access Prometheus. Looks like our containers are up and running. Now I'm going to use localhost colon 9090 port. Press enter. Our Prometheus is running fine. If you see, let's go to our alerts. I don't see any kind of alerts. Let's go back to our rules. I do not see any kind of alert rules here. So there is some problem. Let's jump back to our container and see what's going on. Why are we not seeing these alerts? So for that, I would need my container name first. I would like to copy my container name. So in this case, it would be episode 4 alerting Prometheus 1. Clear the screen. Followed by, I am going to execute this command. What exactly I am trying to do here? I am getting into the container and trying to list /etc/Prometheus folder to check if we have alertrules.yaml file. Press enter. Normally we have alertrules.yaml file, prometheus.yaml file. I see only prometheus.yaml file, so this is the problem here. Looks like we did not add the volumes, I guess. Yes, I can see prometheus.yaml. Let me check if we have alertrules.yaml file as well. No, I do not see. I see alertmanager.yaml file. Looks like we did a small mistake here. So these kind of issues we do in real environments as well. So it's kind of common. So I'm going to quickly add that file here. Alertrules.yaml colon slash etc slash Prometheus. I'm going to do the exact stuff which we have at Prometheus line followed by alertrules.yaml. Now hopefully after adding this particular line, we should be able to see our alert rules in Prometheus. Let me close this real quick and I would do a docker compose down and docker compose up hyphen build. So I'm trying to destroy everything and recreate so that it would be easy. Now let's jump back to our Prometheus, refresh this. Here we are. I can see node alerts. Let me go back to alerts and I can see high CPU usage, 0 active alerts. Inactive, slowly it should change to pending, then it comes to firing. Also, if you look at the Slack channel, we don't have any kind of alerts. Now if you see, it came to pending state. From inactive to pending state. It will wait for 10 seconds here in this particular state and it will move to firing state. Let's look at what exactly happening in our alert manager. I don't see anything yet. Once we have in firing state, we should be able to see in alerting manager as well. Now from pending state to we have it on firing state. You see inactive, pending and firing. Hopefully we should see that in our Slack channel as well. Yes, firing 1, high CPU usage warning. And if you go to alert manager, we can see that here as well. Info, source, silence and also the link. This is how you try to configure self-aware monitoring system. Now let's do a quick recap of today's episode. Node exporter. It try to read the host metric, which is nothing but our sensor. Prometheus evaluates rules. This is our brain. Whereas alert manager routes and dedupes. It is our dispatcher. Slack delivers the message, the voice. Together, it's a production grade alerting pipeline. You built a self aware monitoring system. We can extend the same pattern to memory, disk usage, container restarts. I mean, we can do a lot of stuff with respect to different alert rules. Next episode, we will see a real outage simulation guided by alerts. Subscribe and let's keep building systems that talk before users complain. Thank you for watching and see you in the next video.